Okay, I'm getting ready to do my lemon electrochemical cell fire presentation. So first I'm just going to take my lemon here and kind of roll it a little bit to kind of get the juices flowing. This is a kind of firm, not so ripe lemon. Alright, that should be good. Next I'm going to take my 6 zinc nails and place them into the lemon. Just squirted myself in the eye with lemon juice. Okay, now that I have all 6 of the zinc nails in, I'm going to put the copper clips in. Okay, so now I have all 6 zinc nails and all 6 copper clips in. Now I'm going to connect the first zinc nail to the second copper clip and so on and so forth. This wire is a little bit harder to bend than what I anticipated. Okay, not super perfect, but you can see all of the copper clips are connected to the zinc nails. Now I'm going to take a little bit of steel wool here and place it on the plate. I know in the video they used toilet paper for their timber. I had a Kleenex that flew away. So here's my timber, just a little bit of Kleenex. I'm going to put that on the steel wool. Then I'm going to take my last 2 pieces of wire and connect one to the zinc nail, which is my anode, and the other to the copper clip, which is my cathode. Next, I'm taking the two wires here. I know you're a little bit far away, but nothing is really happening. No spark with the steel wool like in the video. I mean, I think I set up the experiment correctly. Okay, well this isn't working out, so I'm just gonna go over, show you one more time that I did set it up properly. Here's kind of the system that I had. But I will just talk about kind of what should have happened. So an electrochemical cell requires three things, two electrodes and one electrolyte. The electrode that wants electrons more is called the cathode. In this case, that should be the copper clip that wants the electrode more. The electrode that gives up electrons is called the anode, and in this example, that would be the zinc nails. When the zinc is exposed to the citric acid in the lemon juice, the acid oxidizes or removes electrons from the zinc, and that results in positive zinc ions moving into the solution, the lemon juice or the citric acid. The resulting electrons collect in the metal and transfer via the wire into the copper, which we already said the copper is the cathode and wants the electrons more than the zinc does. The electrons are now in the copper, and they pull hydrogen out of the acid and reduce them. This adds electrons, and the result is hydrogen gas. In summary, the electricity that should be made from this experiment is not coming from the lemon itself, but the chemical reaction resulting from the differences in electronegativity between the zinc and the copper. And my guess why this didn't work out, I obviously don't have a tool to measure the voltage or the current that was coming from this setup, but my guess is that there just isn't enough voltage or current to actually produce a spark to light a fire to the steel wool. That makes me wonder if maybe having like a lot of lemons, a bunch of these maybe in a long line, if that would produce enough voltage to actually start a fire. But until then, I think I won't be using this in the wilderness. If I need to make a fire, I will stick to my lighter or good old-fashioned stick and stone. Okay, thank you very much.